Hi guys, so we have an O-level past paper question from the year 2016. The session is October-November. This is question number 10. This question is based on vectors, ratios and transformations. So let's do it. In the question they've given us multiple triangles. The question reads ACB and OCD are straight lines. AC is to CB is in the ratio 1:2. The vector OA is equal to 3A and the vector OB is equal to 6B. Part 1 says express AB in terms of A and B. That means we have to go from A all the way to B and we have to express this in terms of AB. So the vector AB would be when we go from A to O and then we go from O to B. When we add these two vectors, since you're not going from O to A, you're going in the opposite direction, you use negative 3A plus 6B. That's your answer. So you write it over here. 6B minus 3A. The next part says express AC in terms of A and B. That means we have to express AC in terms of AB. First of all, if you look at AC, the vector should be 1/3 of AB, right? Because according to this is one part and this is two parts. So let's multiply 1/3 by the vector AB. AB is 6B minus 3A. When we multiply this, you eventually you cancel out this and this with 3 and you get 2B minus A, which is your answer to this question. 2B minus A. The next part says BD is 5A minus B. Show your working clearly. Find OC is to CD. That means they've told us that this right here is, this right here is 5A minus B. 5A minus B. Okay, let's have a look at it then. So first of all, let me remove all of this. The first thing that we need to understand is we are going from O to C. OC, and then we are comparing this to CD. If we try to find out the vector OD, we would need to go from O to B and then from B to D. So first, let's do that. So OC would actually be OA plus AC. Let's first find this. We are finding OC first. So you go from O to A, then from A to C. So O to A is 3A plus A to C in this part was 2B minus A. Let's add the two. We get OC comes out to be 2A plus 2B. That's one of these vectors. Okay, now let's find CD. How do we find CD? First, we need to find OD. And in order to do that, we need to go from O to B and then from B to D. So OD would be OB plus not OD, but BD. OB is 6B plus BD is given to us in the question. It is 5A minus B. Therefore, OD comes out to be 5B plus 5A. So we have OD and OC, but we don't have CD yet. However, CD would be equal to OD, which is from here to here, and minus OC. So you subtract OC from it. So what we have to do over here is OD we just found was 5B plus 5A and OC is 2A plus 2B. Let's do this. 5B minus 2B gives us 3B and 5A minus 2A gives us 3A. You can also write it in the other way. 3A plus 3B would also work. Now let's compare OC, since we have CD as well, to CD. So OC in this case was 2A plus 2B and CD in our case is 3A plus 3B. If you factorize the 2 comes out of this and you're left with A plus B at the top, and at the bottom 3 comes out of it and you're left with A plus B at the bottom. You can cancel out A plus B and A plus B over here and the ratio is 2:3. So you write it over here, 2:3. The next part says, in the next part they've given us a grid and they've given us two triangles A and B. Part 1 says describe fully the single transformation that maps A onto triangle B. If we connect these points, if you look at these two triangles, We connect these 2 points, and then we connect these 2 points, and then we connect these 2 points. As you can see, the perpendicular bisector of all 3 lines would be over here. This line is therefore y equal to negative x. That means this is a reflection in line y equal to negative x. Okay. The next part says triangle A is mapped onto triangle C by the shear H, in which the y-axis is invariant. The line invariant is the y-axis, and H times 2 and 1 gives us 2 and 3. This 2 and 1 is actually the coordinates of A right over here. Let me remove all other things so that it is clear to us. Okay. So the coordinates of A switch from 2, 1, 2, 2 and 3. That means the distance over here was 2 units and it went up by 2 units. So the distance from the line of invariance was 2 and this went up by 2 as well. So if we look at the next part which says state the shear factor, it is going to be 2 divided by 2, that gives us 1. So this is 1. Now let's draw the other 2 points as well. So the distance of this point right here, let's call this B. Let's remove all other things over here. Okay, the distance of this point from the line of invariance is 2 units, and this would also go up 2 units when this distance is multiplied by the shear factor, which is 1. So it goes over here. So this is B complement, this is the second point, this is the first point. Now let's talk about this point. Let's call this point C. This point has a 5 unit distance from the line of invariance. If you multiply 5 with 1, this means it goes 5 units up. So this comes over here. So this is going to be C complement. So now we can connect all these points and we have a new triangle, that is, let's say this triangle, let's call this triangle C, and that is what the question asks us. So this right here is going to be triangle C, and we're done with this part. The next part says find the matrix that that represents H. So y-axis being the line of invariance, this is the invariant line, would have a matrix which would be equal to 1, 0, 1 and k. The value of k over here is the value of the shear factor. Therefore, we replace k by 1 and our final answer is 1, 0, 1 and 0. Sorry, not 0 over here, this is going to be 1. So we write this value as 1 over here and our final answer is 1, 0, 1, 1 and we're done. I hope this question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button and thank you so much for watching.